Alrighty, folks. So now that you know how you did on the Unit 7 test, I figured it would be okay to go ahead and do some reflection via some points and a few rhetorical questions. And if you're my one student who hasn't taken your test yet, that's okay. I'm not revealing any test answers on this slide, so you can feel free to watch this video. No worries. The first question I do have, though, is how full is your Unit 7 packet? Usually, the fullness of your Unit 7 packet corresponds pretty directly to how well you did on the Unit 7 test. So students who have a lot of empty spaces on their Unit 7 packet, like they didn't do very many of the practice problems, they tend to have not done so well on the Unit 7 test. And vice versa is true, where students who did a lot of practice problems, maybe all the practice problems, there were a lot, tend to do pretty well on my Unit 7 test overall. On a rare occasion, I will see that student who did a bunch of practice and then still didn't perform super well in their Unit 7 test. That might have been an off day, or it could be that you put everything into short-term memory and didn't fully understand. So maybe you're doing a limiting reactant stoic problem, and you do so many of them that you kind of robotically can crank out the quiz the next day, but you don't fully understand what you're doing, or it's only in short-term memory, and so come test time, you can't really tie everything together with the big picture. So maybe that's something that you need to consider going down the road. Another question I have for you is, how many keys are in your bag? That is, are you using those answer keys? You take advantage of those in terms of your practice and your ability to self-assess. It doesn't mean you have to physically take the answer keys and put them in your bag. I know a lot of you guys take pictures of them. I know a lot of you guys look up the electronic copies on Schoology when you go home. But the overall idea is, are you assessing yourself and your ability to do practice problems, and especially the tough ones, towards the end of any given worksheet? Another question is, how did you use those keys? Some people abuse the keys, the answer keys. So obviously none of my worksheets are worth a grade. They're just there for you to practice. And some people will just pick up the answer key before they even do the worksheet, like, oh, yeah, no, this makes sense. I can follow along with this. Hindsight's 20/20. Just because you understand the answer key doesn't mean you could do it on your own without any help if I gave you a fresh set of problems. So I think a lot of people have this false confidence when they look at answer keys too early and too often. So make sure you kind of use them sparingly. Like, you want them there to assess yourself, but at the same time, they shouldn't be your go-to first move whenever you're practicing, and you shouldn't have to use them every second. Another thing to consider, did you bug Mr. P? Did you come and find me when you needed help? I have several students, in fact, I had one on Monday, where they emailed me, like, Mr. Pilcher, when do you have a free period? Sounds good. I'm coming that period. I have multiple questions. I have a lot of students who do that, and it's great. A lot of good examples there. I have students who come and bug me after school. I have students who come and bug me before school. I have students who bug me during lunch. Come find me. If none of those work, don't forget that what happens every time when I pass out a worksheet, those last 10 to 15 minutes of class periods, I come around to every single table and I ask you personally, do you have questions? Do you need help? Or anything like that. And lots of times I'll ask, let's say I ask Billy. I don't have a Billy, okay? But if I did theoretically have a Billy, be like, Billy, do you have any questions? Do you need help with anything? And sometimes I'll have students where they're like, no, I think I'm all good. I think I'm good. I'll be like, okay, Billy, sounds great. But then the next day, Billy gets beat up on the quiz, and it's like, did you actually have questions? And you were too bashful to ask me, or was it you didn't realize you had questions because you hadn't actually practiced and realized that yet? Something to consider, especially if you didn't do great on this test, and you think, I don't really actually ask Mr. P any questions. That could be your biggest problem. The last point about Unit 7 is, how did you use those last 10 to 15 minutes in class? Some people try and pack up early. Some people just kind of stare at the practice worksheets. Some people are just kind of not on task in some fashion. Those last 10 to 15 minutes are clutch, because that's when you are putting pencil to paper, you are getting your hands on things, you are the one that is taking ownership of your learning. And so those are really crucial times, those end of the classes. So think about, do I use those most of the time, or do I pack up early? Am I on my phone? How do you use those last few minutes of class when we're practicing? And here's a positive note. Unit 8 brings hope. This is a rough estimate, but I would say in the last 20 days of school, which is Unit 8, there will be roughly about, best guess, I would say about 200 points in this unit, okay? That means that your grade is not set in stone. So maybe you love your grade right now. Don't take your foot off the gas, because there's a lot of points to be had that could affect that negatively. But let's say you're not thrilled with your grade because of this Unit 7 test. You still have a lot of opportunity to boost that puppy up. Okay, so keep that in mind as well. So Unit 8 brings hope. We have a 30-point quiz next Tuesday, for example. That's based on the materials from today, tomorrow, and Monday. And that quiz, that's half of the points of the unit test we just took, just because it covers a lot of different things. Now, it's pretty surfacey. It's not, I wouldn't say it's a very difficult quiz. You should certainly practice. But it's not going to be like TOEIC where you go really, really in-depth. This is just the introductory quiz to Unit 8. And so I think it's a really good opportunity to really boost yourself. Historically, the average on that quiz is, it's pretty high average. Again, that's when students are just taking a Unit 7 test, they're not thrilled, and so they really put the pedal to the floor, and they do a great job practicing for this quiz. So get ready for that. That's next Tuesday. Let's go ahead and take a look at our packet here. So if you weren't in school to get the hard copy of the Unit 8 packet, you could print it off. It's posted right below this video if you need. Or you could just take notes today and then use your packet tomorrow or the next time you see me in class. So now these notes, they don't follow the Unit 8 packet perfectly, but they do follow it pretty closely. So you can go ahead and keep track. Now, you may want a pencil and a periodic table. Today you won't necessarily need a pencil, but later on in Unit 8, you'll definitely want a pencil, not a pen, because lots of times we have to move things on your paper. It's not that you're making a mistake, but it's that you have to actually move things around. We're going to be doing a lot of drawing, so you want to be writing in pencil so that you can erase. But you can use a pen for today. Like I said, your quiz is on Tuesday. So let's do a little quick review of some stuff from Unit 6. All atoms want 8 valence electrons to be stable. So that's our octet rule. All atoms want 8 valence electrons to be stable. Okay? And what are valence electrons, Mr. Pilcher? Valence electrons, I'll just put VE. Those are electrons in the outermost energy level. So that's that very first blank, the outermost energy level. So you want to keep that in mind there. Okay, and all atoms want 8 valence electrons to be stable. How do I find the number of valence electrons? Well, let's just look at the group number on the periodic table. So we have these group numbers here. Okay, so we got group 1, 2, 3, 4, 5, 6, 7, and 8. Whatever group number an atom's in, that is how many valence electrons they have. So if I randomly select one, like, I don't know, sulfur, how many valence electrons does it have? Well, that would be 6 because it's in group number 6. It's in that 6th column right there. Now, be careful. There is one exception to this rule. Helium, even though it's in group 8, only has 2 valence electrons. So watch out for that. That is an exception to that rule. And you also want to watch out for hydrogen. Hydrogen's an exception in the sense that it doesn't want 8 valence electrons. It only needs 2 to be stable. So hydrogen, right here, it has 1 valence electron, and it just wants 2 to be stable. Helium doesn't have 8 valence electrons, it has 2 valence electrons, and it's happy because it's got its 2 to be stable. So our 2 exceptions are hydrogen and helium. That's a kind of small point, and we'll see that more later. And we talked about ionic bonds a lot in Unit 6. What is an ionic bond? Well, it's a bond made out of ions. Specifically, electrons are gained or lost, so opposite charges attract. So one atom is losing an electron or 2, another atom is gaining an electron or 2, and then a bond is formed. And then a bond is formed between the 2 ions that are made by giving or taking electrons. So sodium and chlorine like to form ionic bonds. Sodium and oxygen like to form ionic bonds. That's just a little note. You don't have to actually write that down if you don't want to. Just a kind of reminder. But ionic bonds will typically involve a metal and a nonmetal. They typically involve a metal and a nonmetal. So somebody from the left side of the periodic table is pairing up with somebody from the right side of the periodic table. So loosely speaking, underneath this umbrella, very loosely speaking, we have metals. And they tend to give electrons. Because these guys usually only have 1, 2, or sometimes 3 valence electrons, it's a lot easier for them to give electrons away instead of trying to gain all the way up to 8. Whereas our nonmetals over here, so these are our non-metals, they tend to take electrons because they have a higher number of valence electrons, like 5, 6, or 7. And so it's a lot easier for them to gain electrons to get to that 8 valence electrons, that magic number for the octet rule, than it is for a metal. So they like to take them. So metals will tend to become positive because they're getting rid of negative charge electrons, and nonmetals tend to become negative because they're gaining negative electron charges. And remember, they should always add up to be neutral. Okay, so our charges always need to add up to be neutral. We looked at this when we were making formulas. So for example, 3 fluorines go with 1 aluminum because fluorines are a -1, whereas aluminum is a +3, etc. So to give you guys a visual, you don't need to draw this, but here's a visual. So we have sodium here on the left. It has 11 electrons total, but 1 valence electron, this little guy right here, okay, that little guy right there. So notice how it's in that outer ring. Chlorine has 17 total electrons, but 7 of them are valence electrons in this outer ring, okay? So what's going to happen is chlorine's like, I just need 1 more to get 8 valence electrons, just 1 more. And sodium's like, I don't even want this one that I have, because if I get rid of it, I can have a full outer shell of 8. So sodium's like, look, how about you just take this off my hands? If I can grab, not the ring. Why don't you just take this chlorine, and then that ring is gone. And so notice how both chlorine and sodium both have 8 valence electrons at this point. And chlorine will become the chlorine ion with a -1 charge. And sodium will become sodium +1 ion with a +1 charge. And what happens here? Opposites attract. So these two fall in love. It's supposed to be a heart. It's a little lopsided. That's what your heart looks like. You should probably seek medical attention. But yeah, opposites attract. So we get that +1 charge and that -1 charge. They're going to come together and form that ionic bond. Okay? And so that's all reviewed for you. So what about something like Cl2? You guys remember Hofbrinkel? So it's like H2. Like, why is O2 O2? Like, how come 2 oxygens bond with each other? That doesn't seem to make any sense. Like, don't you have to have a metal and a non-metal? So here's the situation. You got the chlorine on the left, like, all right, bro, hear me out. I just need 1 valence electron. That's all I want. That's all I need. Just 1. And the chlorine's on the right's like, oh, this is it's kind of awkward because I was actually hoping to ask you for the same thing. Like, I low-key want that electron too. And so like, oh. What do we do? Okay? Because they both want 1 more valence electron to be stable. Okay? So, that's what brings us into...
8 valence.
They want 1 more to get to 8 so that they're stable. No, they both have 7. 1, 2, 3, 4, 5. Oh! Good catch! 7. Weird. Okay, nice catch. So they both have 7 valence electrons, and they want 1 more. So this brings us to covalent bonding, okay? Who has a job? Boom, okay. Where do you work? Great. Who's your work bestie? Bernice?
Bernice? Is that a boy or a girl? Bernice with a B.
Oh, with a B. Okay, Bernice, cool. You would say, if you were trying to explain Bernice to somebody, you'd be like, this is Bernice, my blank. What would you call them?
Best friend.
What else could you call them?
Co-worker.
Co-worker. You say Bernice is my co-worker. All right, let's say Faith gets her pilot's license and she's flying a plane. The person sitting next to her flying the plane is her co-pilot, okay? The word co means share. I share work with this person. I share flying this plane with this person. And what do you think valence referring to? Valence electrons. They're sharing valence electrons. It's bonds that happen when you're sharing electrons. So it involves the sharing of electrons. It involves the sharing of electrons. Faith's like, I kind of want to fly the plane now. Okay? It typically only involves nonmetals. If you think about it, that kind of makes sense, right? Because nonmetals are the only ones that want more electrons. Like sodium is not going to want to share it. Like, bro, I don't even want this electron. Somebody take it. I don't want to share it. I want to get rid of it. But the 2 nonmetals are like, we both kind of want that, so why don't we cut a deal here? Okay? So they each throw 1 into the pot, and they share. By the way, hydrogen is a nonmetal. So hydrogen does like to share valence electrons. Remember, it only has 1 valence electron, but it's only looking to get 2. So hydrogen is often looking for just 1 more valence electron. So you'll see hydrogen involved in covalent bonding all the time.
Whatever you say.
It's truth. Facts. Big facts. Okay. So again, it only wants 2 total valence electrons. So here's a bunch of examples of some covalent bonding. Got CO2, Cl2, NH3, O2. You don't have to write those down if you don't want to, but you've seen those formulas before, and you may have been like, wait, so chlorine and chlorine, isn't that like a -1 and a -1? That doesn't make any sense. So you may have wondered that before. Covalent bonding explains. Yes, sir.
I am not understanding what's going on at all right now.
Well, we'll get there. We're actually about to draw some visuals that might help. But John, the real quick summary is with ionic, and one atom throws electrons at another. Whereas in covalent, the two atoms agree to share some electrons in the middle.
So they're playing catch.
No.
Yes. So
They used to like.
they both have to have 4, or they both.
They both want 8 in their outer shell.
So they need. I mean, how does that doesn't make sense?
That's how they bond. That's how like we use off and like when they're like touching together. So like that's how they're bonding. But when they're casting going back is like what we learned before previously. You know what I mean?
No.
I kind of like that explanation. It might help if we draw here in a minute, so this might get some clarity.
Okay.
I like that.
So Lewis dot structures, these are easy. Last 2 minutes here. They show an atom's valence electrons. And we got rules for single elements. Okay? So they share an atom's valence electrons. So fill each side one at a time. You don't have to write this down. I'll explain it here shortly. And maximum of 2 on each side except for bonding. So these 2 little bullet points, you don't have to write these down. Because you're like, wait, what do you mean 1 on each side? What does that mean? I will show you, and I think it'll make perfect sense. Okay? So here's some examples right here. I haven't said that one yet. I'm about to. Okay? So oxygen, how many valence electrons does oxygen have?
1,
6. It's in group 6, so it has 6. Here's how you fill them out. Notice, I'll do one at a time. I'm going to go north, east, south, west with it. And I'll double them up when I have to. So here we go. 1, 2, 3, 4. Now I have to double up because I have run out of sides. 5 and 6. Bromine has 7. Here we go. 1, 2, 3, 4, 5, 6, 7. You guys want an ego boost? How many does potassium have? 1. Done. That's it. And so here's our last blank available to make any of these single electrons. So notice that this is a single one, not a double one. But any of these single ones, those are used for bonds. In other words, oxygen has 2 singles. That means it likes to make 2 bonds. Bromine has 1 single. That means it likes to make 1 bond.